Chapter 9, number 46. A pencil standing upright on its eraser end falls over and lands on a table. As the pencil falls, its eraser does not slip. The following questions refer to the contact force exerted on the pencil by the table. Let the positive x direction be the direction the pencil falls, and the positive y direction be vertically upward. So that's our setup. A. During the pencil's fall, is the x component of the contact force positive, negative, or 0, and explain. And then B. Is the y component of the contact force greater than, less than, or equal to the weight of the pencil? And again, explain. So here what we really want to be talking about is what's happening to the center of mass of the pencil, which is probably something like here, and then kind of moves through a circular arc like that. And we can see that since it picks up some sideways momentum, it picks up a momentum in the x direction, so delta p x is greater than 0, and delta p, of course, is going to be the impulse, which is going to be the force times the time. So the fact that delta p is greater than 0 implies that f of x has to be greater than 0. So the answer for part A is f sub x must be greater than 0. And then for part B, we can see that delta py is less than 0. So that implies that the impulse in the y direction, which is fy delta t, is less than 0. So fy is less than 0. But here we should be a little careful because this is the net force. Actually, so of course is this. For the x direction, the net force is just fx. But for the y direction, the net force is really the contact force minus the weight. And we need that to be less than 0, which means that the contact force must be less than gravity. So we end up that is less than gravity, so that it accelerates downward.